हॅलो फ्रेंड्स, राणा अकॅडमी या यूट्यूब चॅनलवरती आपणा सर्वांचं स्वागत आहे. आपण स्टार्ट केले आहे केमिस्ट्रीची वन शॉट सिरीज, ज्यामध्ये आपण पाहणार आहोत 15 ते 20 मिनिटांमध्ये प्रत्येक चॅप्टर, जेणेकरून तुम्हाला रिव्हिजनमध्ये फार मोठा फायदा भेटेल. चला तर मग व्हिडिओला सुरुवात करूया. तुम्ही या चॅनलवरती जर नवीन आला असाल तर प्लीज या चॅनलला सबस्क्राईब करा आणि बेल आयकन हिट करा. चला तर मग आपण सुरुवात करूया व्हिडिओला. आपला पहिला चॅप्टर आहे केमिस्ट्रीचा 11th क्लासचा सम बेसिक कॉन्सेप्ट्स ऑफ केमिस्ट्री. Some important points. Anything which has mass and occupies space is called matter. Matter exists in three physical states: white, solid, liquid, and gas. In solids, these particles are held very close to each other in an orderly fashion, and other there is not much freedom of movement. In liquids, particles are close to each other, but they can move around. However, in gases, the particles are far apart as compared to those present in solid or liquid states, and their movement is easy and fast. तरी स्टेटमेंट काय म्हणताय, आपण आता गॅसेस स्टेटचे पार्टिकल्स आहेत तर त्यांच्यामध्ये मुवमेंट हे फास्ट होणार, जसं सॉलिड आणि लिक्विड स्टेट्सपेक्षा मुवमेंट इझी अँड फास्ट. सॉलिड्स हॅव डिफायनाइट व्हॉल्यूम अँड डिफायनाइट शेप. तर सॉलिड पार्टिकल्सला काय असणार आहे, डिफायनाइट शेप असणार आहे आणि डिफायनाइट व्हॉल्यूम असणार आहे. लिक्विड्स हॅव डिफायनाइट व्हॉल्यूम बट नॉट द डिफायनाइट शेप. They take the shape of the container in which they are placed. The liquid have definite volume but not definite shape. Liquid ला definite volume तर आहे पण definite shape नाही आहे. They take a shape of containers in which they are placed. तर लिक्विडला कोणता पण शेप येऊन जाईल. जर तुम्ही त्याला भांड्यामध्ये ठेवाल तर भांड्यासारखा शेप येऊन जाईल. आपण वॉटर, फॉर एक्झाम्पल वॉटर पाहूया. वॉटरला काय आहे, डिफायनाइट व्हॉल्यूम आहे पण डिफायनाइट शेप नाही आहे. तर ते आपण हे एक्झाम्पल घेऊ शकतो लिक्विड पार्टिकल्समध्ये. गॅसेस हॅव नायदर डिफायनाइट व्हॉल्यूम नॉर डिफायनाइट शेप. तर गॅसेसला तर व्हॉल्यूम पण डिफायनाइट नसते, लिक्विडला व्हॉल्यूम डिफायनाइट तर असते आणि डिफायनाइट शेप पण नसते. तर गॅसेस पार्टिकल्स जे असतात त्यांना डिफायनाइट व्हॉल्यूम आणि डिफायनाइट शेप नसतो. दे कम्प्लिटली ऑक्युपाय द कंटेनर इन विच दे आर प्लेस्ड. जर तुम्ही ज्या कंटेनरमध्ये ठेवाल त्या पद्धतीचा त्याला शेप येऊन जाईल. A mixture contains two or more substances present in it, which are called its components. A mixture may be homogeneous and heterogeneous. तर मिक्सरचे दोन टाइप्स असणार आहेत, होमोजिनियस आणि हेटेरोजिनियस. In a homogeneous mixture, the components completely mix with each other and its composition is uniform throughout. Sugar solution and air are thus the examples of homogeneous mixtures. नंतर आपण होमोजिनियस मिक्सचर पाहत आहोत. होमोजिनियस मिक्सचरमध्ये शुगरचं सोल्युशन, एअर अँड दस एक्झाम्पल्स ऑफ होमोजिनियस मिक्सचर. हे होमोजिनियस मिक्सचरचे एक्झाम्पल्स आहेत. हेटेरोजिनियस मिक्सचर पाहूया आता. The composition is not uniform throughout and sometimes the different components can be observed. For example, the mixture of salt, sugar and grains and pulses along with some dirt places are heterogeneous mixtures. तर मिक्सचर कसं हेटेरोजिनियस मिक्सचर आपण कोणत्या मिक्सचरला म्हणू शकतो, जे मिक्सचर आहेत फॉर एक्झाम्पल मिक्सचर ऑफ साल्ट अँड शुगर, ग्रेन्स अँड पल्सेस, ह्यांना आपण हेटेरोजिनियस मिक्सचर म्हणू शकतो, कन्सिडर करू शकतो. द कंपोनेंट्स ऑफ अ मिक्सचर कॅन बी सेपरेटेड बाय using physical methods such as simple hand picking, filtration, crystallization, distillation, etc. Pure substances have characteristics different from the mixtures. They have fixed composition of copper, silver, gold, water, glucose are some examples of pure substances. तर प्युअर सबस्टन्सेसचे काही एक्झाम्पल्स दिलेले आहेत आपल्याला. प्युअर सबस्टन्सेसमध्ये फिक्स्ड कंपोजिशन असते. प्युअर सबस्टन्समध्ये आपण पाहूया कॉपर, सिल्वर, गोल्ड, वॉटर, ग्लुकोज हे एक्झाम्पल्स आहेत प्युअर सबस्टन्सचे. Glucose contains carbon, hydrogen, and oxygen in a fixed ratio, and thus, like all other pure substances, has a fixed composition. Also, the constituents of pure substances cannot be separated by simple physical methods. An element consists of only one type of particles. These particles may be atoms or molecules: sodium, copper, silver, hydrogen, oxygen, etc. are some examples of elements. They all contain atoms of one type. However, the atoms of different elements are different in nature. Some elements, such as sodium or copper, contain single atoms held together as molecules of the element. Thus, hydrogen, nitrogen, and oxygen gases consist of molecules in which two atoms combine to give their respective molecules. When two or more atoms of different elements combine, the molecule of a compound is obtained. The examples of some compounds are water, ammonia, carbon dioxide, sugar, etc. The atoms of different elements are present in a compound in a fixed and definite ratio, and this ratio is characteristic of a particular compound. The SI system international day units, abbreviated as ASD, have seven base units, and they are listed in table 1.1. Base physical quantities and their units: length, mass, time, electric current, thermodynamics, temperature, amount of substance, luminous intensity. The mass of substance is the amount of matter present in it, while weight is the force exerted by gravity on an or object. The mass of a substance is constant, whereas its weight may vary from one place to another due to change in gravity. तर मास काय असणार आहे, वेरी असणार, वेरियस मतलब डिफरंट असणार आहे डिफरंट प्लेसेसवरती, चेंज ड्यू टू चेंज इन ग्रॅव्हिटीमुळे मास हे डिफरंट प्लेसेसवरती डिफरंट शो होणार आहे. वॉल्यूम हॅज युनिट्स ऑफ लेंथ क्यूब, सो SI system. Volume has units of mm cube, a common unit liter, which is not an SI unit, is used for measurement of volume of liquids. 1 liter is equal to 1000 milliliter. 1000 centimeter cube is equal to 1 dm cube. Density of substance is its amount of mass per volume. SI unit of density is kilogram per meter cube. This unit is quite large, and chemists often expresses the density is in gram per centimeter. There are three common scales of measure temperature: degree Celsius, degree Fahrenheit, and degree and Kelvin, where K is the unit is the SI unit. Kelvin scale is related to Celsius scale as follows: K is equal to degree Celsius plus 273.15. Degree Fahrenheit is equal to 9 upon 5 degree Celsius plus 32. In scientific notation, exponential notation, any number can be represented in the form of n into 10 to the power a, where 10 to the power n, where n is an exponent having positive and negative values of n, and n can vary between 1 to 10. Thus, we can write 232.508 as 232.32508 into 10 to the power 2. In scientific notation, note that while writing it, the decimal had to be moved to the left by 2 spaces, and same is the exponent. 2 of 10 in the scientific notation. Similarly, 0.00016 can be written as 1.6 into 10 to the power minus 4. Here the decimal has to be moved for 4 places to the right, and minus 4 is the exponent of in the scientific notation. Scientific figures are meaningful digits which are known with the certainty. The uncertainty is indicated by writing the certain digits and last uncertain digits. Thus, if we write a result as 11.2 milliliter, now we say the 11 is certain and 2 is uncertain, and the uncertainty of would be plus minus 1 in the last digit. Unless otherwise stated, the uncertainty of plus 1 in the last digit is always understood. There are certain rules for determining the number of significant figures. These are all stated below. All non-zero digits are significant. For example, in 285 centimeter, there are 3 significant figures, and in 0.25 milliliter, there are 2 significant figures. तर आपल्याला सिग्निफिकंट फिगर्स फाइंड आउट करायचे आहेत. सिग्निफिकंट फिगर्स दिलेले आहेत, ज्याचे करून एक्झाम्पल्स पण दिलेले आहेत, ज्यानेकरून आपल्याला सोप्यात सोपं समजता येईल. एक्झाम्पल्सला पण सोप्यात सोपं समजून घेता येईल. चला तर मग नंतर पुढचा बघूया पॉईंट. Zeros preceding to first non-zero digit are known not significant. Such zero digits indicates the position of decimal point. Thus, 0.03 has one significant figure and 0.0052 has two significant figures. Zeros between two non-zero digits are thus 2.005 has four significant figures. Zeros at the end of right of the number of are significant provided they are on the right side of the decimal point. For example, 0.200 gram has three significant figures, but if otherwise the terminal zeros are not significant if there is no decimal point. For example, 100 has only one significant figures, but 100 has three significant figures, and 100.0 has four significant figures. Figures such numbers are better represented in scientific notation. We can express the number 100 as 1 into 10 to the power 2. Now, for one significant figure, 1.0 into 10 to the power 2 for two significant figures, and 1.00 into 10 to the power 2 for three significant figures. Counting numbers of objects, for example, two balls or 20 eggs have infinite significant figures, as these are exact numbers can be represented as writing infinite number of zeros after placing a decimal. 2 is equal to 2.0000 or 220 into 2.000. And the numbers written in scientific notation, all digits are significant. Example, 4.01 into 10 to the power 2 has three significant figures, and 8.256 into 10 to the power 3 has four significant figures. तर ते आपल्याला सिग्निफिकंट फिगर्स कसे फाइंड आउट करायचे, सिग्निफिकंट फिगर्स कसे काढायचे याबद्दल एक्झाम्पल सहित समजवण्यात आलेलं आहे, जेणेकरून आपल्याला समजण्यासाठी सोपं जाईल आणि आपल्याला ध्यानात पण ठेवण्यासाठी इझी जाईल. चला तर मग नंतर बघूया. आता पुढचे नेक्स्ट पॉईंट असणार आहे लॉ ऑफ कन्झर्वेशन ऑफ मास. स्टेट्स दॅट मॅटर कॅन नायदर बी क्रिएटेड नॉर बी डिस्ट्रॉयड. तर लॉ ऑफ कन्झर्वेशन ऑफ मास काय म्हणतं आहे की जे मॅटर आहे ते नाहीतर क्रिएटेड केलं जाते ना डिस्ट्रॉयड केलं जाते. मतलब त्याचं क्रिएट पण होत नाही आणि डिस्ट्रॉय पण होत नाही लॉ ऑफ कन्झर्वेशन ऑफ मासनुसार. लॉ ऑफ डिफायनाइट प्रॉपोर्शन्स states that a given compound always contains exactly the same proportion of elements by weight. Law of multiple proportions states that if two elements can combine to form more than one compound, the masses of one element that's combined with the fixed mass of the other element are in the ratio of small whole numbers. Gay-Lussac's law of gaseous volumes. This law was given by Gay-Lussac in 1808. He observed that that when gases combine or are produced in a chemical reaction, they do so in a simple ratio by volume, provided all gases are at same temperature and pressure. In 1811, Avogadro proposed that equal volumes of gases at the same temperature and pressure should contain equal number of molecules. In 1808, Dalton published a new system of chemical philosophy in which he proposed the following: matter consists of individual atoms. All the atoms of a given element have identical properties, including identical mass. Atoms of different elements, different in mass, components or compounds are formed when atoms of different elements combine in a fixed ratio. Chemical reactions involve recognition of atom. These are neither created nor destroyed in a chemical reaction. Dalton's theory could explain the laws of chemical combination. One atomic mass unit is defined as a mass exactly equal to 1/12 the mass of one carbon atom, 12 atom. Molecular mass is the sum of atomic masses of the elements present in the molecule. It is obtained by multiplying the atomic mass of each element by the number of its atoms and adding them together. The mole of the amount of substance of the system which contains as many elementary entities as there are atoms in 0.012 kilograms of carbon atom, carbon 12. Its symbol is a mole. When the mole is used, the elementary entities must be specified and may be atoms, molecules, ions, electrons, other particles, or specified groups of such particles. This number of entities in one mole is so important that it is given a separate name and symbol. It is known as Avogadro constant, denoted by Na in honor of Amedeo Avogadro. An empirical formula represents the simplest whole number ratio of various atoms present in a compound, whereas the molecular formula shows the exact number of different types of atoms present in the molecule of a compound. Many times the reactions are carried out when the reactants are not present in the amounts are as required by the balanced chemical reaction. In such situations, the one reactant is in excess over the other. The reactant is which is represented in the lesser amount gets consumed after sometimes, and after no further reactions takes place, whatever be the amount of the other reactant present, hence the reactant which gets consumed limits the amount of product formed and is therefore called the limiting agents. मास परसेंटचा फॉर्म्युला दिला आहे मास ऑफ सोल्यूट पर 100 ग्रॅम ऑफ सोल्युशन. मास परसेंट इज इक्वल टू मास ऑफ सोल्यूट अपॉन मास ऑफ सोल्युशन इंटू 100. It is the amount of solute in grams dissolved per 100 gram of solution. Example, 10% solution of sodium chloride means 10 gram of solid sodium chloride present in 100 gram of solution. Mole fraction. It is the ratio of number of moles of a particular component to the total number of moles of all other components. Mole fraction of solute is equal to number of moles of solute upon number of moles of solute plus number of moles of solvent. In case of dilute solution, WA upon MA is greater than WB upon MB. Molality. It is defined as the number of moles of solute per 100 gram of 1 kilogram of solvent. Molality is equal to number of moles of solute upon kilogram of solvent. Molality, number of moles of solute upon liters of solution. WB upon MB into 1000 upon volume of solution in ml. तर इथे आपला सम बेसिक कॉन्सेप्ट्स ऑफ केमिस्ट्री हा चॅप्टर संपवतो. तुम्ही या चॅनलवरती जर नवीन आला असाल तर प्लीज या चॅनलला सबस्क्राईब करा. प्लीज लाईक शेअर अँड सबस्क्राईब. थँक्यू सो मच फॉर वॉचिंग.